Hi students, welcome to Hayagreev Foundation YouTube channel. Today I am going to explain about the topic magnetic effect of electric current. So we want to learn about the effects of electricity. There are three effects of electricity. First one is heating effect, next one is magnetic effect, another one is chemical effect. So in this heating effect, already last lesson electricity I explained about that clearly. Now I am going to explain about magnetic effect of electricity. So before that we have to learn about magnet. So what is mean by magnet? Normally we know. So magnet having two poles. So two poles it will attract with the other magnet or other magnetic material. So this one common term we know. So magnet when we are suspend freely. Freely means a magnet we have to hang freely. So it will rotate and finally it will come to rest in north-south direction. So the pole which is towards geographic north is called north pole. The pole which is towards geographic south is called south pole. So each magnet having two poles, north pole and south pole. So next magnetic material will attract, or magnet will attract iron, nickel, cobalt, like that ferromagnetic materials attracted by magnet. So next one, two magnets if we are taking like poles, like south and south pole or north and north pole will repel each other. So like poles are repel each other, then north and south pole of two magnets will attract each other. So what we can say means unlike poles are attract each other. So these are the magnetic properties. So freely suspended magnet comes to rest in north-south direction. So like poles are repel each other and unlike poles are attract each other. This is common fact in magnet. So using the magnet we have to learn about magnetic effect of electricity. With the help of magnet, now I am going to explain about magnetic field and magnetic field lines. Now I am taking a bar magnet having two poles, one is north pole, another one is south pole. So the region around by the magnet by which the magnetic material will experience a force is called magnetic field. So magnetic field is nothing but the region surrounding by the magnet by which other magnetic material will experience force is nothing but magnetic field. So next we have to learn about magnetic field lines. So what is mean by magnetic field lines means this is nothing but this magnetic field is represented by a set of lines that are called magnetic field lines, or simply we can call field lines. So magnetic field lines are nothing but the magnetic field are represented by a set of lines are called magnetic field lines. So now I am going to draw the magnetic field lines of magnet. How need to draw magnetic field lines of magnet, bar magnet, I am going to explain. So we have to take one bar magnet and one small magnetic compass. So magnetic compass having needle, in that one end is marked red. This red end indicates always north pole. So with the help of that magnetic compass and the direction shown by north pole, we are going to draw the magnetic field lines of magnet. So now near north pole we have to keep a magnetic compass. So magnetic compass we are keeping means it will show deflection. So deflection shown by north pole we have to draw a line. So we have to move the magnetic compass from north to south in the form of arc. So the deflection shown by north pole we have to mark with dot lines, that is nothing but the magnetic field lines of magnet. Example, magnetic compass we have to move towards south pole. So this magnetic north pole showing the direction of magnetic field lines. So this method we have to draw the magnetic field lines of magnet around it. So now I am going to explain about the properties of magnetic field lines, very important topic. So now This is the diagram for magnetic field lines around a bar magnet. So with the help of this diagram, we have to learn about the properties of magnetic field lines. So first property of magnetic field lines is magnetic field lines always start from north pole and end in south pole. This is outside the magnet. So outside the magnet, magnetic field lines always start from north pole and end in south pole. But inside the magnet, magnetic field lines will start from south pole and end in north pole. This is the first property of magnetic field lines. So second property, magnetic field lines always forms closed loop. So closed loop means it is like a closed loop, it will form always. So magnetic field lines always forms closed loops. This is second property of magnetic field lines. So third property is magnetic field lines never cross each other or never intersect each other, that we can use. So it never cross each other. So two magnetic material never cross each other. So that is third property of magnetic field lines. So next, fourth property. So if number of magnetic field lines are more, in that area magnetic field strength is more. So through diagram we come to know more magnetic field lines present around the near the poles. So that area near the poles of the bar magnet, magnetic field lines are more. So magnetic field strength is very high near the two poles of the magnet, but at the sides of the magnet, magnetic field lines are very less. So this will give less strength of the magnet. So magnetic field strength is very high near the poles than the sides of the magnet. So only the magnet will attract by other magnetic material easily by the poles. So these are the properties of magnets. So one question they may ask, why magnetic field lines never cross each other or never intersect each other? So that answer is, if maybe magnetic field lines may be crossing each other, means at the point of intersection, any one pole of magnetic compass want to show the deflection in two direction, that is practically impossible. So only magnetic field lines never intersect each other or never cross each other. So these are important 2-mark question. Write the properties of magnetic field lines or draw the diagram of magnetic field lines of a bar magnet. Now I am going to explain about magnetic field due to current carrying conductor. I am using the conductor by connecting the battery with the help of plug key. So now plug key is closed, so current is flowing through the conductor. Near this straight conductor, we need to keep a magnetic compass. So magnetic compass already we know it will experience force or it will show deflection by moving other magnet nearby it. But in this experiment, we are not going to use any other magnet, only one magnetic compass we are going to use, that's it. So one more thing what we are using means straight conductor. So this straight conductor carrying current with the help of battery. Now current is flowing through the conductor, the magnetic compass or magnetic needle in magnetic compass is going to show the deflection when current flowing through the conductor. When current flows through the conductor stops, the needle will come to rest in north-south direction. So if current again it is flowing through the conductor, again the magnetic needle is showing deflection. So through this experiment, the scientist Hans Christian Ørsted concluded that the current carrying conductor produces magnetic field around the conductor. This is nothing but magnetic effect of electricity. So what is magnetic effect of electricity? The conductor carrying current produces magnetic field around it. That is magnetic effect of electricity. Next, we are going to reverse the direction of current. First, we had given current in rightward direction. Now, we are allowing to pass through the current through the conductor in leftwards. So, we are reversing the direction of conductor. Then the magnetic needle deflection also shown in reverse direction. What it's shown in first experiment. So, which side it's shown deflection? Just opposite side it will show deflection in this experiment. So current is going to reverse, the direction of magnetic field also going to reverse. This discovered by Hans Christian Ørsted, or magnetic effect discovered by Hans Christian Ørsted. Through this experiment, he concluded that current carrying conductor produces magnetic field. So electricity and magnetism both also interrelated to each other. Current is going to convert into magnetic field. Through this only they unified two different lessons, electricity and magnetism, together one lesson, that is called electromagnetism. So now I am going to explain about magnetic field around a current carrying straight conductor. So straight conductor, how the magnetic field is going to produce, I am going to explain now. So one cardboard or wood paper sheet we have to take, and like this paper sheet, the straight wire we have to pass through this sheet, middle of the sheet we have to pass, and that straight conductor we have to connect it with variable resistor, that is nothing but rheostat. With the help of this we can change the amount of current flowing through the conductor. So ammeter we are connecting, so battery with the help of plug key. So direction of current is always from positive terminal to negative terminal of the battery. So positive terminal outward we have to give, negative terminal inward. So this is the direction of current flowing through the conductor. So now we have to use some iron fillings we have to spread around the paper. So now when current is going to pass through the conductor, we have to tape the paper. So iron fillings will arrange automatically around the conductor. So iron fillings will automatically around the straight conductor in the form of concentric circle. So this direction of magnetic field around a straight conductor given by right hand thumb rule. So I am going to explain about right hand thumb rule now. So now imagine this is a straight conductor. So we have to hold a straight conductor in our right hand. So here thumb indicates the direction of current. So direction of current is moving this direction. So thumb point indicates the direction of current, and the finger encircle the conductor indicates the direction of magnetic field around the straight conductor. So magnetic field around the straight conductor is nothing but a circle. So it's circle means concentric circle, we are going to get number of circles we can make, but different magnitude of magnetic field. So this is right hand thumb rule. Imagine we are holding a straight conductor in our right hand. Thumb indicates the direction of current, and the finger encircle the conductor indicates the direction of magnetic field. This is nothing but right hand thumb rule. Now I am going to explain about magnetic field due to a circular current carrying conductor. If the current carrying conductor is circular shape, what is the direction of magnetic field? I am going to explain now. So circular coil we have to insert in between the cardboard sheet. This is nothing but cardboard sheet. So now the two ends of the circular coil want to connect with the help of battery, with the help of plug key. So now plug key is closed, that time current is start to flow through this circular conductor. So circular conductor current is flowing means around this circular conductor the magnetic field lines is like concentric circle. Like this curve we will get around this, but the center of the conductor the magnetic field lines is parallel, or center of the circle the magnetic field lines will pass like a straight line. So nearby the two coils the magnetic field lines will produce like a curve or circle. So nearby in between the two coils it will be curve, but exactly center of the circular coil the magnetic field lines will pass like parallel or straight at the middle of the circular coil. So this is nothing but the magnetic field produced by a circular coil. Or one more is therefore the direction of magnetic field of circular coil also given by right hand thumb rule. So imagine I am holding a circular coil in my right hand. So now the thumb point indicates the direction of magnetic field. The finger encircle indicate the direction of current. So this is nothing but right hand thumb rule for circular coil. Already I said right hand thumb rule of straight conductor. Now this is right hand thumb rule of circular conductor. So thumb indicates the direction of magnetic field. The finger encircle the conductor indicates the direction of current. So in circular coil, the direction of magnetic field is tangential direction. So now I am going to explain about magnetic field around a solenoid, current carrying solenoid. Also, what is mean by solenoid? Normally that is nothing but a conductor. So conductor, imagine this is a cylinder, hollow cylinder, insulated cylinder. So surrounding by this a long insulated copper wire, we have to wind in the form of helix. So that is nothing but solenoid. So helix is like looking like spring. So long conductor, wind in the form of helix is nothing but solenoid. So now I am going to explain about the magnetic field produced by current carrying solenoid. So current carrying solenoid always act like a magnetic field, or it's look like a magnet or acting like a magnet. So how the magnetic field lines produced around the magnet, like that a small piece of strong magnet also produce magnetic field. So current carrying solenoid is equivalent to the bar magnet. So now I am going to explain with the help of diagram how the magnetic field lines passing through the solenoid. Inside the solenoid, the magnetic field lines are uniform. So it will act like one direction. Otherwise, if we are going to reverse the direction of current, the magnetic field lines also going to reverse. But inside the solenoid, the magnetic field is uniform. When current is flowing through the solenoid, it is going to produce magnetic field inside the solenoid. When current is off, there is no magnetic field inside the solenoid. So it is used to produce electromagnet. What is mean by electromagnet? Where we are using means number of electrical instruments we are using electromagnets, like loudspeaker we are using electromagnetic cranes, we are using electromagnets. Next, generators we are using. So number of ways we are using electromagnets. So what is mean by electromagnet means inside the solenoid we need to insert a soft iron rod. So soft iron rod means purest form of iron we have to insert inside the solenoid. So when current is flowing through the solenoid, it will produce magnetic field inside the solenoid. So that soft iron is going to get magnetized. So soft iron will act like a magnet. So it will attract the iron particles or other ferromagnetic materials. It is going to attract. When current flowing through the solenoid is going to stop, that time it will lose its magnetic property. So it won't exhibit like magnet.
ನಾವು ಮಾಡ್ತಾ ಇರೋ ವಿಡಿಯೋಗಳು ನಿಮ್ಗೆ ಇಷ್ಟ ಆಗಿದ್ದಲ್ಲಿ ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ಪಕ್ಕದಲ್ಲಿರೋ ಬೆಲ್ ಐಕಾನ್ ಅನ್ನ ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ ನಾವು ಮಾಡೋ ವಿಡಿಯೋಗಳ ನೋಟಿಫಿಕೇಶನ್ ನಿಮಗೆ ಮೊದಲು ಬರ್ತದೆ. ಯಾವುದೇ ರೀತಿ ಸಂದೇಹಗಳಿದ್ರೆ ಕಮೆಂಟ್ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ತಿಳಿಸಿ. ಹಾಗೆ ಈ ತರಗತಿಗಳು ಹೆಚ್ಚಿನ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ತಲುಪುವಂತೆ ಶೇರ್ ಮಾಡಿ.